Space is big. We're not talking human scale big, we're talking incomprehensibly big. To put this into perspective, the Empire State Building is 1,454 feet tall. We would have to stack 270 people to reach the top. And then, in order to stretch across the known universe, we would need 3 octillion Empire State Buildings. That's a 3 followed by 27 zeros. The universe is so big, in fact, that scientists have suggested it might be infinite, which really brings us to a level of large beyond human comprehension. I'm a lover of mathematics, and all things infinite fascinate me. Why? Well, I guess it's because infinity kind of blows my mind. In theory, I can understand that something is infinite, but in application, I just can't see it. And then my question becomes, well, where did this concept come from? Today, I'd like to introduce you to some of the most beautiful mathematical images. Infinite graphed equations, tucked away neatly in a corner of geometry. Fractals. Drawn out in endlessly repeating patterns, they are some of the most bizarre and beautiful shapes that emerge when graphing equations. Observed everywhere, from trees to blood vessels, even in the arrangements of the galaxies above. Fractals are a mathematical concept existing independent of human invention. Come with me as we explore several key traits of these mathematical wonders. Their self-similarity, their infinite nature, and their conceptual existence. All mathematical evidence pointing to a creator. According to the Fractal Foundation, fractals are infinitely complex patterns that are self-similar across different scales. They are shapes made from the graphs of equations. What makes these patterns special, however, is that when we zoom into a fractal, we see the same image repeating itself over and over and over. Let's take a look. Meet the fractal tree. To create a fractal tree, we start with a vertical line, like so. Now, here's the rule. At every layer of this fractal, this line is going to split into 2 smaller lines. Now we've got 2 lines, and our pattern tells us to split each of these in 2. We can repeat this process over and over and over to create a fractal tree, like so. Now, since every layer of this fractal follows the same pattern, every layer looks exactly like the one before it. So this branch of the fractal tree looks exactly like the tree as a whole. It's self-similar. This concept of fractal self-similarity is illustrated in nature. As a matter of fact, according to the Encyclopedia Britannica, the term fractal was coined in 1975 when mathematician Benoit Mandelbrot needed a word to describe the self-similar patterns found in natural objects. Look at a tree, for example. Just as our fractal tree repeatedly splits, every tree you see will branch off into progressively smaller branches, which split off into even smaller twigs and finally into leaves. This fractal pattern is found inside your body as well. According to the Center for Fractal Design and Consultancy, the designed self-similarity in our blood vessels helps transmit blood most effectively throughout our bodies. Furthermore, human lungs were designed as fractals, with layers of bronchi and bronchioles that split 7 times, following a pattern of such efficiency that if we were to unfold them, their surface area would cover an entire tennis court. Could such efficiency have come through natural selection? It was designed, created. Self-similarity is just one of a fractal's key traits, however. The second is infinitude. Mathematically, fractals are infinite. They continue forever. Now, the Oxford Dictionary defines infinity as the concept of something that is unlimited, endless, or without bound. This trait of infinitude has 2 key parts, being unlimited and being a concept. Let's take a look at both. To understand the unlimited nature of a fractal, behold a rope. Now, let's just say that this rope is infinitely long. Because infinity is endless, we can pull and pull and pull this rope, but we'll never reach the end. In the same way, we can look closer and closer at a fractal. We'll see the same images repeating themselves over and over and over and over and over, but we'll never reach the end. To see this unlimited nature in action, let's take a look at another famous fractal, Sierpinski's triangle. According to the Boston University Department of Mathematics, this fractal is created by drawing an upside-down triangle inside every right-side-up triangle. We can follow this self-similar pattern to draw in 3 more upside-down triangles, then 9 more, and so on. Now, because this fractal is infinite, we can zoom into the triangle over and over and over again, but we will never reach the end. And this brings us to our third and final trait, the conceptual nature of fractals. Because these self-similar patterns are infinite, fractals are considered a mathematical concept. The Oxford Dictionary defines concept as an idea or principle that is connected with something abstract. In other words, it's the abstract ideas that exist behind what we see. For example, I cannot destroy the idea of a fractal any more than I can destroy the idea of the number 7 by erasing it off my page. Fractals such as Sierpinski's triangle are infinite concepts that are limited by the finiteness of our physical universe. According to NASA, we can only observe a finite volume of the universe. We cannot observe infinity in the limited universe we have been given, and therefore, we cannot see to the end of infinite fractals. But this brings us back to a key question. Where did the concept of the fractal originate? Astrophysicist Dr. Jason Lisle really challenged me with these words. We don't normally think of God creating numbers because they are abstract, not physical. But of course, all things are made by God, even the abstract things. Humans in a finite universe did not create the abstract rules of mathematics. They discovered them. In fact, fractals existed far before humans came to understand them. They were written into mathematical formulas that have existed since the beginning of time. To see these formulas in action, let's take a look at one of the most famous fractals, the Mandelbrot set. This is the Mandelbrot set. In 1975, mathematician Benoit Mandelbrot used an IBM computer to create the first computer-generated map of this fractal. Like nearly all fractals, the Mandelbrot set is mathematically generated using an equation. In this case, new z equals old z squared plus c. This fractal is an illustration of this equation graphed out over infinite points of iteration. I can see why Mandelbrot used a computer to plot out all of these points. But that's just the thing. According to IBM, while Mandelbrot was the first to map out this fractal with a computer, the equation itself was discovered by French mathematicians in 1918, over 50 years earlier. Fractal formulas are written into the laws of mathematics. This showy image was first plotted out by Mandelbrot, but its equation has existed since the beginning of time. And it's the same for Sierpinski's triangle and our fractal tree. Humans didn't create these fractals. And here's where it gets fun. Fractal mathematics is found all throughout nature. A study by the Institute of Physics found that snowflakes follow fractal geometry and can be generated using fractal equations. And our buddy Mandelbrot used fractal geometry to study coastlines and even found that galaxies are distributed across the universe in fractal patterns. Fractals are a mathematical concept whose self-similar patterns are reflected all throughout nature. And if we choose to look closely, here we have an opportunity to witness stunning evidence of our Creator. Romans 1:20 tells us that since the creation of the world, God's invisible qualities, his eternal power and divine nature have been clearly seen, being understood from what has been made. God's very qualities can be seen in the infinite mathematical nature of fractals. And yet, well-known intelligent design critic Richard Dawkins once said that faith is the great cop-out, belief in spite of the lack of evidence. Is this really the case? Is there no evidence to support our belief in a creator? I don't believe so. God left his fingerprints all throughout mathematics. Evidence of his creation right here. Fractals. And now the question is, what are we going to do with it? Are we going to lean into it and hear the song creation sings to its creator, even in mathematics? Or do we choose not to glorify him and instead turn to our own finite understanding? Geometry stretching to infinity. Fractals provide stunning evidence of our creator. Thank you.